Algebras. Welcome to your Chapter 11 Lesson 1 notes. Before I dive into Lesson 1, I just want to go over what Chapter 11 is going to cover. So, Chapter 11 is going to deal with quadratic functions. Now, for the last 4 chapters, we've been dealing with stuff that prepared us to solve quadratic equations. Now, these were equations that had an x squared and equal to 0, right, for our standard form. So there was that one variable present, it was x, and we had it squared, and we were dealing with how do we solve for x? How do we get answers for x when we've got that? Well, now we're going to have two variables present and x is squared. This makes it a function. And when we're dealing with quadratic functions, I will also refer to them as parabolas. So I'll go back and forth as far as how I reference the fact that I'm looking at quadratic functions and parabolas, right? We're going to start today with identifying parts. So we'll be looking at parabolas and we'll call certain places on them certain names. Then we are going to find axis of symmetry, vertex, and roots algebraically. Then we're going to graph quadratic functions. Then we'll apply how we use quadratic functions in word problems. Then we'll stop, review, take our quiz for chapter 11. And then there's all this other fun stuff about quadratic functions. We'll first review what vertex form will look like. We'll have notes and a day of practice. We will then graph quadratic functions and linear functions on the same graph. Then we will learn how to solve quadratic linear systems algebraically, so finding the intersection points using algebra. And then we'll have a day of practice going back and forth, solving a system algebraically, solving a system graphically. There is a Regents review laced in here, as well as exam review and exam for chapter 11. Okay? So why don't we dive in to chapter 11, lesson 1? Starts out with this nice colorful diagram of a quadratic function graphed on a coordinate plane, a 4x4 coordinate plane, right? These are the pieces we need to be able to identify in our quadratic functions. So we need to be able to identify what the axis of symmetry is, and that's this invisible vertical line that cuts the parabola in half, gives it symmetry on each side. Notice that line is vertical, straight up and down, okay? On that line is going to be something called the vertex. You may also hear it referred to as the turning point of the parabola, because sometimes it's called the turning point because that is literally where the parabola hits to and then turns back around and goes the other way symmetrically from where we were. That turning point is either a maximum or a minimum depending on the shape of the parabola. The x-intercepts are also known as the roots or the zeros. And both of those should sound familiar because we have referenced roots or zeros when solving quadratic equations for x. The stuff we did in chapter 8 and chapter 10 was turn functions into equations and find where they touch or cross the x-axis. That's what we were doing. Really cool how that comes together, right? And then lastly, but certainly not leastly, is this is the y-intercept, the one point where the parabola will touch or cross the y-axis. And I do say 1 point because notice that x value will be 0. And because this is a function, that means it can only use an x value once. Okay, it can use a y value more than once, that's fine, but it's a function and x values can only be used one time. So the x-intercepts, there can be more than one of. The y-intercept, there can only be one of. Okay. All these things that I say right here are right down here, color coded and all. So make sure you know what all the pieces on this picture reference. That is what we're going to be labeling on our graphs of quadratic functions. So let's dive in. The directions here say we're going to properly identify these parts below. We're going to find the axis of symmetry equation. I'll explain that. We'll find the vertex point. I'll explain that. We are going to tell whether that vertex point is the maximum or the minimum, meaning the lowest point or the highest point. We're going to identify the y-intercept point, and we are going to identify the roots or zeros. Okay. So, as I stated on the first page, the axis of symmetry is a vertical line that cuts the parabola in half. It's a line. Lines have equations. Since it's vertical, it's always an x equals wherever it touches the x-axis, and that's it. That's the equation part of this. So the equation part is always going to be x equals whatever number I'm touching at the x-axis. Whereas the vertex point is always going to be the x value of the axis of symmetry and the y value of that point. The y-intercept point will always be 0 and whatever the y value is. Okay? And then the roots will always be whatever x value 0, whatever x value 0. Okay, those are also points. The majority of what we deal with here are points. There's one line and 3 types of points. Okay, the vertex, of course, on C still is a point, but is that point the highest or the lowest? Okay, so let's do this one together. The axis of symmetry, and you can visually see the axis of symmetry. Look, it's this line right here that's cutting your parabola in half. So notice I do a dotted line or a dashed line straight down my parabola to indicate that this is my axis of symmetry. I'll abbreviate axis of symmetry as AOS, but obviously say the 3 words, axis of symmetry. And it's x equals whatever x value I'm touching on the x-axis, which is 1. So x equals 1 is the axis of symmetry. Now, the turning point or vertex is always on the axis of symmetry, which means it shares an x value with the axis of symmetry. So this point right here is on the axis of symmetry and is the turning point of this parabola. So the value of this point, and I'll abbreviate TP, right? The value of this point for x is definitely 1 because it's right on the axis of symmetry, or you can do V, right? TP or V for that guy. It's definitely 1, but let's see where we are y-wise. So -1, -2, -3, -4. So +1, -4. Is this point a high point or a low point? It's down here, so it's a low point and what we call a minimum, or just min works for me. Then D, identify the, excuse me, y-intercept point. Well, let's see where we touch or cross the y-axis, right there. We know the x value on this is 0. So we know the x value on this guy is 0. Let's see, -1, -2, -3. So 0, -3 is my y-intercept. And last but certainly not least, identify the roots or zeros, right? So I'll just call them Z on here. We know that both of these will have 0 as a y value. So these are coordinate values, and they are the x values of where we touch or cross the x-axis. You can call them R for root, or you can call them Z for zeros. But this is -1, 0. And this over here is 1, 2, 3, 0. There you have it. That's how we label the picture. And then that's how we state what each of those are. Okay? Do it again. Just going to zoom out so you can see my previous work and the directions. Okay, so let's see here. Oh, facing upside down. Axis of symmetry. Well, the y-axis is the axis of symmetry. But I was asked specifically for its equation, so I can't just say y-axis because that's not an equation. The equation of the y-axis is x equals 0. So the axis of symmetry is x equals 0, which, as we know, is the y-axis. I'll label that right here. Okay. Now, the turning point is, of course, on the axis of symmetry. Right here is my turning point. So label that guy TP or V, right? Turning point or vertex, either word works. I use them interchangeably. This is 0, -2. And again, it's the same x value as the axis of symmetry, so not surprising. See, is this a maximum or a minimum? Well, maximum is the highest point of a parabola. This was a minimum going the other direction, right? So it stands to reason this is the highest point of the parabola. This is called a maximum or just a max. Now we label the y-intercept. Well, wait a minute. X equals 0 is the y-axis. This is also, the turning point is also the y-intercept. Interesting. I'm going to put that right here too. Y-int and turning point. So and E is the roots or 0. Whoa, whoa, whoa. No roots or zeros. I'm not touching or crossing the x-axis. Does that mean there would have been real solutions here? This is a no real solutions. So this is what we dealt with in chapter 10 when we had no real answers to plugging in and solving in the quadratic formula. This is what it looks like in practice. It means that parabola just won't touch or cross the x-axis. That's why there's no real roots, no real solutions. Interesting, right? How that all starts to come together. It comes together even more when we start to do the algebra part tomorrow, right? Okay, right now what I want you to do is I want you to do this third one down here on your own. Okay, so you've seen my 2 examples. Let's pause it here and let's get you trying all of this on your own. Label the graph and state what those values are for each of these, just like I did before. So you got to label the graph and you have to come back and state over here. Okay, both. Give that a try. Pause it right here. And then we'll come back and show the answers. Okay, so this was nice and interesting, right? I've got everything labeled on here, so let me just go over. The axis of symmetry is the vertical line that touches the x-axis at -4 right here. So x equals -4 is the equation of the axis of symmetry. That point on there that is the turning point is -4, 0. So that's right here, vertex turning point. It is a minimum. It's the bottom of my parabola. It's the lowest point that I get to. The y-intercept, I didn't put it doesn't exist. I didn't put there's none. I put it's unknown. And the reason is because is this parabola with the arrows continuing on going to touch the y-axis? Yes. Is it in this picture? No. So according to this picture, it is unknown to me, but I know it's going to happen. So I didn't put none. Okay? It wasn't going to happen. The roots aren't going to happen there. It's none. But this I just don't know. Now, also here, the roots or zeros are the same as the turning point. There is one root, right? That's when you got one real root out of your quadratic formula. So that's when there would be a 0 as the discriminant value. Okay, so that's how these things, these pieces come together. All right, moving on. We're going to label the parts of our parabola right here. Okay, so we have the arrows pointing and we'll fill in the box for each of these, right? This box is pointing to the axis of symmetry, the vertical line that cuts the parabola in half. And again, I'm just going to put in parentheses, I label it AOS to stand for axis of symmetry. Okay. This point right here, we can see is on the y-axis. So this is the y-intercept on my quadratic function. These values right here are where the parabola is touching and crossing the x-axis. So these are my zeros or roots or x-intercepts. I'm going to stop at zeros or roots. And then, of course, right here, this point that's right on the x-axis, or excuse me, the axis of symmetry, this point that's right on the axis of symmetry, the very bottom of my parabola, is the vertex, which, of course, I also call the turning point at times. You know, I go interchangeably with those guys. Now, again, if the parabola, we say, opens up, or I like to use smiley face, right? The parabola is a smiley face. It has a bottom, a minimum. If the parabola is a frowny face, it has a top, and that's called a maximum. And we just looked at that in the examples that we did together. And it kind of stands to reason, right? That if it's heading this way, it goes up to the top and then back down. Oh, that's the max. That's the highest it goes. If it's heading down, 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 and then hits a point and starts going back up, oh, that's the bottom. That's the minimum. That's where it goes to. All right. Last piece, because I'll ask about it in the notes, is what we call an increasing interval or a decreasing interval. It just means that as your x gets larger, as your x increases, is the y getting bigger or getting smaller? If the y is getting bigger, we call it increasing. If the y is getting smaller, we call it decreasing. And we always look to this left to right because that's how our x value increases, is left to right. Smallest x to largest x, left to right. Okay, so that's how we're also going to look at these. Now we state the increasing or decreasing intervals as inequalities. So we state it as an x value of where we're going with this. Okay, so if I want to look at this and call it an increasing interval, from here on, y is increasing. So what's the x value starting here? It's positive 1. So x greater than or equal to 1 is an increasing interval. Okay, now look at y's here. As x is increasing, y is getting smaller and smaller and smaller. Over here, y is decreasing. But where does it stop decreasing? Right here at the axis of symmetry. What's the axis of symmetry value? X equals 1. So what's the value of the decreasing interval? All 1 and less. X is less than or equal to 1. Let's do it again. Okay. Increasing interval, y is getting bigger and bigger and bigger and bigger until, boom, the axis of symmetry, which also happens to be the y-axis here, so it's x equals 0. So when all the x values are smaller than 0, y is increasing. So x less than or equal to 0 is your increasing interval for y. Decreasing interval for y, again, deals with x and 0, but this time, all the x values bigger than 0 means y gets smaller. So x is greater than or equal to 0. Pause it here, and you try the last one. Base it on the axis of symmetry value for x. Okay, base it on the axis of symmetry value for x and go from there. Okay, so my axis of symmetry value of x is -4. Okay, remember that we're going left to right. So as we go left to right here, y is getting smaller and smaller and smaller. Now these values are all less than or equal to -4 for x. These values over here are all greater or equal to -4 for x. And this is where my y value is getting bigger and bigger and bigger. So that's how I know which side of the axis of symmetry to call greater than -4 or less than -4. Okay, that's how I know what to do. This is y decreasing. This is y increasing. All right. Go ahead and make sure you know what each of these pieces is on your parabola. Okay? Make sure you know what each of those is and how I abbreviate them, and how I move forward from there. Let me know if you need help labeling your graphs or stating the values, but I think that's going to be okay. If not, we'll do it together, and good luck, and I will see you soon.